The Jacobs Medical Tower 2 expansion is a progressive infrastructure initiative aimed at modernizing the site and enhancing its capacity to support increased medical services. The core features of this expansion are established early in the process, beginning with a detailed demolition plan that addresses the removal of existing structures, pavement, and utilities. This effort lays the groundwork for new construction while prioritizing the preservation of surrounding infrastructure. Essential utilities and structures designated to remain in service are clearly identified in the demolition plan, with specific safeguards outlined to maintain their integrity throughout construction. Simultaneously, the erosion control plan integrates best management practices, or known as BMPs, to minimize environmental impact and ensure regulatory compliance during site development.
So taking a look at the site topo for the proposed Jacobs Medical Tower 2 location, we find that the existing parking lot there is on flat level terrain. In comparison, the proposed outpatient pavilion and central utility plant expansion are on uneven terrain and will require about 10,000 cubic yards of cut in total. So in order to reduce the net export of material, we recommend raising the foundation elevation of the proposed Jacobs Medical Tower 2 and transferring soil from the outpatient pavilion and utility plant expansion areas. And the proposed access to the Jacobs Medical Tower 2 will primarily be on the south side from the access road by the East Campus office building in order to separate congestion between the two towers.
The geotechnical study for this project revealed the site's soil properties and the strength parameters needed for the structural design of the building's foundation. The soil properties and strength parameters were calculated by the analysis of cone penetration testing that was performed at the site. Pictured here is a profile of the soil that shows what was found. We found 6 layers of alternating soil and can see that it is made up of only coarse material, which was sands and sandy mix. Using the data, we were able to classify the site a site class D, which is very weak. Due to this, a normal shallow foundation would fail with the calculated column loads. Since a shallow foundation was not an option, we recommended a deep pile foundation system that the structural engineer designed in greater detail. This deep pile foundation system would help distribute the column loads into the soil and was the best option for the Jacobs Medical Center Tower 2 building.
In regards to stormwater, we found that this site is not located in a flood zone, and by using the rational method for peak flow analysis, we found that the most of the runoff is largely attributed to the impermeable surfaces, such as the existing asphalt parking lot where Jacobs Medical Center Tower 2 will be located, and the temporary structures location for the outpatient pavilion. We have recommended occupying the area outside of the footprint of Tower 2's building with permeable surfaces like a bioretention basin at a low elevation point and a permeable pavement entrance to promote infiltration, treatment, and the reduction of runoff within that drainage management area. We also recommended the construction of green roofs on both the outpatient pavilion and the expansion of the central utility plant that were also accompanied by vegetated swales to capture its excess runoff. These best management practices prioritize infiltration and the treatment of runoff, which closely followed UCSD's stormwater management plan and ISI Envision standards. Overall, we were able to achieve a Gold Envision rating for this project and provide beneficial impact onto the local watershed.
The structural engineering requested on the UCSD health project was an analysis of the existing site and development of preliminary foundation system for the proposed Jacobs Medical Center Tower 2. The difficulties in this reside in its location in a seismic zone, coupled with a strict occupancy and importance factor requiring stricter analysis according to OSHPD 1 standards, which then modifies the California Building Code to the amended sections. I assigned a special steel moment resisting frame to the superstructure in order to evaluate the axial forces transferred to the foundation. The size of the loads dictated the use of deep foundation system, and locally available augers narrowed the pile sizes between 2 and 3 feet. These piles will extend to 50 feet deep based off of the side friction analysis and ultimate bearing capacity of the piles. As you can see here in the foundation plan, I opted for four group pile caps for the interior column load transfer, and 3 group pile caps for the exterior as they are taking less loading. The pile caps themselves are completed at a finished grade, with grade beams connecting each group together to prevent individual deformation from warping the special steel frame, as can be seen here in the detail on sheet S1.2. An 11-inch reinforced concrete slab is then to be poured on top and around the column bases, which will be fixed to the pile caps themselves. Once this goes into full production, they will want to modify as they see fit to match the architectural drawings and be sufficient for the structural changes that they request themselves.
This project included an in-depth water system analysis as well as a sewer system analysis. Both of these are an important part of a new building project since we need to know if the existing infrastructure is able to accommodate all of the new pressures and strengths. The sewer system study that I conducted showed us that the existing system of pipes will not be able to withstand all of the new pressures that will be put on the pipes. The main sewer line will have to be increased from 4 inches to 15 inches in diameter in order to move all of the new and old flows to the central utility plant. The water system study that I conducted took into account all of the potable uses and non-potable reuses. Treated water is able to be reused as irrigation water for the green areas on this campus. The water system analysis showed that the new buildings will not overstrain the existing infrastructure and therefore does not require any upgrades.